Hello, my name is Matt. I'm an SE at Fortinet. Today we'll be discussing remote access VPN using native clients in Windows and Mac OS X. Of course, if you already own a FortiGate, there's a couple of remote access options already for you inside FortiClient. You have SSLVPN access and IPSec VPN access. But perhaps you're one of those that has requirements that justify using the native clients only on their endpoints, right? So that's what we're going to be talking about today. Unless you are new to the industry, you've seen the list of options available in Windows before, as far as VPN access is concerned. PPTP, L2TP, SSTP, and IKEv2. On Mac OS, your options are a little bit more limited. You have L2TP, you have IKEv2, and you have a Cisco-compatible IPSec client. If we look at available options on both platforms, we quickly notice that the commonality is L2TP and IKEv2. L2TP has a few shortcomings that will generally would make me lean towards IKEv2, which is a more modern standard that supports better authentication flexibility today. I'm going to make a quick note, however, on PPTP. There are many reasons why you probably shouldn't be using PPTP. First reason, doesn't support split tunneling as far as server-driven split tunneling. You have to do that on the client side, and that's not really a scalable way to do things, right? The second one is the performance isn't as great, right? There's a couple of layers of encapsulation. It's using TCP. It's using JRE underneath. And it doesn't really reconnect as easily as more modern options. But the biggest reason why you shouldn't use that is the security issue, right? So as you can see from the Wikipedia article pertaining to PPTP, there's quite a few problems here, right? So stay out of it. For this session, we'll be using IKEv2, but we'll be using it with certificates. So let's talk about the components we're going to be using today. There's a Windows client, there's going to be a Mac client, there's a FortiGate, and there will be an emulated set of servers behind the scenes. I'm using loopbacks for those on the FortiGate. They're not real servers, but you'll get the idea. It's just for testing the policies. And finally, but not the least, we have a Windows 2012 server that's running NPS and the certificate authority from Microsoft. As I said earlier, we'll be configuring IKEv2 today. However, it's important to note that most authentication in IKEv2 is going to resort to using EAP. EAP is Extensible Authentication Protocol. You can view this as a protocol that typically uses a radius server and has a set of plugins that supports various mechanisms for authentication. And there's a lot of them, as you can see. However, most platforms have a limited set of protocols, extensions, if you will, that they'll support within the EAP portfolio. And one of those that has been fairly popular is TLS. It essentially is a mutual certificate authentication extension within the Extensible Authentication Protocol. So we'll be using certificates both on the client side and on the server side. This is our Windows server. It doesn't have many roles deployed. It primarily has the network policy server, the NPS server, which is the radius server from Microsoft. And it has the certification authority from Microsoft also. We've deployed that with an integrated primary CA here. So if you were to look at this certificate here, this is our certificate authority. It's a private CA, so it's not publicly trusted. It's trusted by the Microsoft environment. So if a computer would be a member of this Active Directory, it would generally automatically trust this CA. So you can see in here that we have a name for that certificate authority. I've already taken a note of this before. The expiration date is, well, we do hope we're going to live all that long, so 2111. And then if we look inside the list of key usages, you'd see that we have certificate signing, which is the key usage that makes this a CA certificate. It can sign other certificates. Quite simple. As I probably said before, EAP uses Radius as a backend, so you can't really use local accounts anymore with IKE version 2. You'll probably be using a Radius server, and that's probably for the better because typically your user database is sitting on an Active Directory, for instance, in most organizations nowadays at least. So we have our NPS server here that's configured. It has a Radius client defined, which is our FortiGate, and it has two policies at this point that are configured to authenticate two groups from Active Directory and return specific values so that we can distinguish who users belong to on the FortiGate side. We'll be looking at that a little bit later. Without going into too much detail about the certificate system, What's important to note is that it functions based on commonly agreed trust. So the various endpoints that are involved in here are trusting the same authority. And that authority, in turn, is the one that grants identities to the endpoints. This model works so long as the central authority is secure. That's why there's generally a lot of security measures applied to ensure that the certificate authority private keys are kept in a very secure fashion. This is a private C infrastructure that we're working with today, but there's best practices to follow if you do deploy a certificate authority. You probably want to read more on that from Microsoft's information sources. For EAP-TLS to work, the client certificate will need to meet certain requirements on top of being trusted, right? So obviously the trust aspect is important. It has to be issued by a certificate authority that we trust. It has to be valid from a time standpoint. So if the certificate is expired, that won't work either, right? A certificate to be usable, we require a private key for it. Certificates work with asymmetric cryptography, so there's a public key which which can be made public as the name suggests, and there's a private key. If you don't have the private key, you can't use this for authentication purposes. In the case of EAP-TLS with an NPS backend that is going to match to users in the Active Directory, there's a requirement that the subject alternative name contain the principal name of the user. That's the nomenclature, so user1 at fortiqc.local in my example, the last part being the name of my domain. And finally, the enhanced key usage has to contain the client authentication usage. So if you are missing client authentication, you won't be able to use that certificate for EAP-TLS, and you may get an error when you try to use it. For the server certificate, we'll be looking at pretty much the same information. Obviously, we need to ensure that it's been issued by a trusted CA. In this case, our server is called winad.fortiqc.local, and it's been issued by the same certificate authority as the user certificate, whether it's valid and whether we have a private key, right? One additional change as opposed to the client certificate is that on this side, we will need the server authentication extended key usage. And we also need a subject alternative name to contain the host name of the server. We'll see a little bit later where this is configured, but this is important for the macOS clients, which will use that as a match criteria for the remote ID field in the configuration. On our Radius server, the certificate that I just mentioned when describing the server certificate match criteria has been imported in the personal certificate repository for the computer, right? So you would basically set this as a machine certificate, if you will. That will make it available in the Radius policy. So if we open one of these policies under constraints where we have defined that we're using smart card and other certificate, which is Microsoft's way of saying EAP-TLS, in our case, we can select this certificate, winad.fortiqc.local, which is the server certificate. While we're in NPS, the policies that we have there's two of them. There's one for group 1 and there's one for group 2. And they are identical except for the fact that one of them is matching a distinct group. And also on the vendor-specific attribute side, we are returning a string, which is the Fortinet group name attribute. It's a vendor-specific attribute that is from the vendor Fortinet, which has vendor code 12356, and that attribute is attribute number 1. So if you configure attribute, you'll see that we have an ID of 1 here. That's actually Fortinet group name. That's the name of this attribute. I'll probably put a reference to our VSAs in the description on this video. And we are typing a string here, which is group 1. It's going to have to match on the FortiGate. This is how we're going to be able to tell that a user was matched by the group 1 policy on the Radius server, the NPS server, and that user belongs to group 1. We don't have an LDAP here in terms of authentication, so we can't just look up groups and memberships directly. So Radius requires that when we accept a connection, we pass back this attribute to the FortiGate so that it knows which group a user is a member of. One topic that's important to address is the security of your certificates. This is the certificate template console, which you access by from the certificate authority management console by right-clicking and clicking manage on the certificate template section. This is where you would configure various templates for assignment to various duties. So you could create a policy template that will allow users to request specific types of certificate in this list. I have a custom template that I created for my domain here. And one of the important options in there is whether you allow the private key to be exported or not. Now that's important for the Windows environments where this not having this option checked is very likely to prevent users from taking their certificates away from their office computer, right? So if you have managed assets, probably best to be unchecking this option to make sure that a certificate cannot be exported out of a computer and onto a computer that is not normally authorized to connect to your network. That would be the best way to prevent that from happening. It's normally not as simple to share this information in the first place anyway. Typically you'll be making those requests automatically behind the scenes, and users won't really get involved in the certificate request process. It just happens in a Microsoft environment by itself, and so typically they won't really know where this information is. But obviously, security by obscurity aside here, you probably want to make sure that they can't even export the keys. Might be a way to do that anyway if you're very crafty, but at this point we're edging our bets here. On a Windows endpoint that's a member of the Active Directory, generally you'll be able to deploy certificate automatically without any sort of user involvement. So the certificate template that I created earlier is something that I've assigned a GPO policy for, and it automatically grants users certificates. So accessing a certificate store for a user account on a Windows machine that is a member of the domain results in that certificate being present. So as far as provisioning, this part is really simple to automate. On a Mac, this certificate is going to be a bit more involved of a process, so you'll need to go to keychain access on your OS X computer, and within the certificate assistant, request a certificate from a certificate authority. Once you're in there, you'll enter the information that you for the user account that you want to request a certificate for, and you'll have to go and submit this information manually to the certificate authority. So if we filled in the user principal name correctly and the common name is just the user's full name, we'll be saving this request to disk. And then from a web browser, if you've installed these web services for the certificate authority, you should be able to access the certificate authority and make the request. So we'll just log into the CA here. And then you can hit request a certificate, submit a request using a base64 format. And then we'll be heading into be just displaying the request that we've just saved. And we need to take this output here, which is the base64 encoded certificate request, and paste this inside the saved request. And we'll be requesting a user certificate based on this. Hit submit, and that should provide you with the certificate. What you'll then do is import this certificate inside the keychain access, and that will give you the certificate that you need in order to connect. Once you've completed this part correctly and re-imported the newly issued certificate, you should be able to see that you have a user certificate in your name issued by the CA, and if you look down in the list, you should see an attribute called NT principal name, which should be your UPN for your user account. That's really important. That's the extension that will be looked at for by the NPS server in order to map you to an actual user in Active Directory. So the certificate obviously may also require that you trust the CA. Currently, it is stated that it's valid because I've already taken care of that. But the secondary step that you're going to need to ensure you do on a Mac platform is to download the certificate authority certificate for FortiQC WinAD CA, in my case, my private CA, and ensure that this certificate is trusted. On a Mac, the way to verify trust of a root authority is to open that certificate inside your keychain access again, And once you've imported it, you'll have to double click the entry and you'll have a trust section at the top. This is our CA server. By default, this will be set to use system default. You'll probably want to change the EAP section here so that it at least is set to always trust. You are free to configure what you wish at that point here. Just setting that to always trust across the board is also an option, although you may not need all the various options here. I suspect you would probably need EAP and IP security at this point. The rest of the options are probably not necessary by default if you're just using this for VPN access. Let's mark a pause in our certificate configuration and discuss the FortiGate configuration at this point. I've hit the CLI because there's a few options that cannot be configured in the UI today, and this is just easier for me generally, personally at least, to go through. So if we look at the common VPN configuration on a FortiGate, it's always something that consists of phase 1 and phase 2 configuration objects. And so our remote access VPN here is no different. We are defining the external interface. In my case, this is port 1. We have an IKEv2 parameter that's defined here. Authentication method is set to signature. Peer type is set to any, contrary to popular belief generally on certificate authentication. This is usually set to match a peer object if you're doing certificate authentication, at least in IKEv1. But in our case, we're using EAP, and therefore we're not using the IKEv2 native certificate authentication system, but rather using the EAP system. And so you have to leave that set to any. And this is just possibly counterintuitive, but it's notably important if you're using EAP. As far as proposals are concerned, this is the set that I've found that natively will work for both OS X and Windows as a platform. Unfortunately, on the Windows side, the default remains that we are requesting AES 128 and SHA-1. I believe this could be changed from a GPO standpoint. I haven't really pushed the concept too far here. I'm just using the native options here that allow both types of clients to connect without too much additional configuration overhead. The big ticket items here are to enable EAP and then ensure that we send the request to the client. That's the default option for this parameter. So it's only pretty much enabling EAP that will essentially turn this on for IKEv2 and allow authentication to happen. You'll notice that there's a certificate set here, right? So there's a test VPN at fortiqc.ca. And so far we've been discussing this fortiqc.local domain, which is not a public domain in the first place, right? And so this is the outer connection layer, if you will. So as the connection occurs, your users are probably going to connect to a well-known host name like this, right? So something that can be resolved publicly. And this has to be trusted also. It's not part of the EAP exchange. It's part of the exchange that happens before that, right? So we have to, when we're establishing a connection to a given host name, we want to make sure that we're trusting that part, right? And I'm not too sure if OS X and Windows behave the same way as far as that's concerned, but I believe that's the case. So your own testing may yield different results at that point. And we'll look at where this is used, at least on the OS X client side, a little bit later. But it is an important parameter. It also means that there is a certificate on the FortiGate itself. This particular certificate is actually not even signed by the same CA, which is probably going to be your case generally. Your internal CA will not be signing your external certificates. That probably wouldn't work from a trust standpoint, right? So this is where you'll use a wildcard certificate or any sort of existing certificate that you've already got on the FortiGate, perhaps for other purposes that are authenticating public inbound requests, such as SSLVPN, for instance. The rest of this is really just mode configuration. We are going to assign IP addresses in the 1058.58.1 to 10 range, and we are including a split tunnel configuration. There's only a single entry in there, and my testing so far suggests that there's only a single entry read from OS X when it receives split tunneling configuration. It does not appear to support having more than one entry in there. So unfortunately, if you're across two ranges on the private range and you want to use split tunneling, you're probably going to be out of luck here with IKev2 because at least if you want to support split tunneling in your configuration. The phase 2 section of this is straightforward. It links to the phase 1 and the proposals are identical. We've disabled PFS here. It could probably be enabled again. Again, it depends on the defaults that are set on the Windows and the OS X side of it. And then we're actually carrying all subnets, so these are wildcard selectors. This is not, again, what governs what gets to go inside the tunnel. The split tunnel configuration is what's going to define what traffic is going to enter this tunnel, right? So the configuration on the VPN side is fairly straightforward. Obviously, you'll notice that we're not talking about a radius server anywhere in there, and that's because we're doing that inside the user definition. So if we move over back to the UI here and go inside our VDOM user section, radius servers, in this section we have a server called AD, which is the NPS server. So we've configured that already in this configuration here. And this is simple. It's the server IP and the secret key that's been configured in the radius client on the Windows NPS side. Your connectivity test is going to work, but your test user credentials is probably not going to work if you try to do that with the type of configuration I've done. In my case, I've disabled auto legacy authentication and hashes, such as PAP and CHAP and MS-CHAP. And so the test, as it uses usernames and passwords with PAP, CHAP, and MS-CHAP, and it doesn't understand certificates, it's not going to succeed. So if you want this feature to work, you'd have to re-enable the authentication algorithms that it uses in order to test. So past that, the radius server is referred to from the groups. So we are going to create two groups. There's actually a third one here, which is called NPS, quite simply, and it matches a remote group of the radius server and any as the group definition here. We're going to contrast this with the other two groups, this is the important string that we discussed earlier, which is returned by the radius server. In this case, group 1 and group 2 are the strings that are matched here. That's the vendor-specific attribute that is being returned by the NPS server that we're using here in order to match incoming connections to the correct group. And all of this comes together at the policy level. So we have 3 policies and the tunnel interface being the source for all of them. And you'll notice that we have a distinct group here for each 3 policies. The first one essentially allows clients to talk to each other, to ping each other at this point as a quick test. That's pretty much all you can do. But if you have voice over IP, if you have any sort of direct peer-to-peer requirement in your environment, this is going to be essential to allow these remote clients to connect to each other on top of accessing your infrastructure. If you have a lot of teleworkers and they need to and they call each other using soft phones, this type of policy is going to be necessary in order to allow that traffic. And then the second and the third policy are there in order to test our policies. So if we have distinct access requirements for different groups from an Active Directory standpoint, these policies are going to allow us to validate that this is indeed respected here. So group 1 should be able to connect to IP 1 and 3, and group 2 should be able to connect to IPs 2 and 3. So we'll run a quick ping here to validate that in a moment. Those are not actual servers, they're just loopback interfaces on the FortiGate that I'm using for testing here, but the concept is the same. If you add a standard interface configured here, you would get the same results with servers. At this point, the configuration is identical, right? When you configure the Windows client in order to use that certificate that we've already deployed, you'll head over to the VPN section on Windows 10, and that will allow you to add a new VPN connection. The VPN provider is the Windows built-in provider, and you'll configure your options at this point, IKev2 and certificate, and then finally no username and passwords. We're using just certificates at this point. I've already done that. But one important aspect of this is that if you want to edit this profile again afterwards, if you go in there, you don't have a a whole lot of options in here. And so it's important to understand that this actually creates a pseudo interface. And if you hit the good old network connections panel here, this is where you'll see that your Office connection is available here and has a much deeper set of properties available that you can edit, right? So here we notice that we're indeed connecting to that outer certificate, the one that's on the device. This is the connection point for our tunnel, right? And then on the security tab, we have the type of VPN set to IKEv2. And on the EAP section, we are selecting certificate. There's quite a lot of options on the Microsoft side in terms of EAP protocols that are supported. But we are using EAP-TLS, which is the certificate option here. On the properties, this is where you have some flexibility on the Microsoft side as to just how far you're pushing the trust exercise. This is the secure configuration that you have here. This is within the EAP tunnel, so we're really talking about those FortiQC.local certificates in our example here. So we're going to first make sure the client verifies the server's identity. Obviously, you want to make sure that the certificate at the remote end is something that you trust. And when we say verify, we also want to verify that we're connecting to a specific server. And that name that you see here, WinAD FortiQC local, is the server name of the certificate that's installed on the NPS server. You wouldn't have to check that if you wanted to just limit yourself at making sure that it's a valid certificate, right? And then you would pick which CA is allowed, is trusted by your client here. So we're picking our private CA here as the CA of trust for this connection. And we notice that we don't have to trust anything else at this point because this happens within the EAP tunnel itself. The outer connection, I've already trusted the certificate that was assigned to the FortiGate itself. And so we don't have to handle that part here. In my case, I'm connecting to, I know the name of the server that I'm connecting. Notice that you can put wildcards here and make sure that, so for instance, if you wanted to just connect to any host that is in the domain of use here, so you could just type the following / here and try and do that on a French keyboard. That's going to be painful. Well, we're not going to do that. So I'm going to connect to winad.fortiqc.local. Simple enough. And once we've done with the configuration, we just have to hit the connect button on the tunnel. And once we've hit the connect button, the tunnel establishes and should report errors in the case of any error, but in our case, it was well configured already. We can test the configuration and make sure that we can reach the systems that we're supposed to reach. Remember that this is user 1, so we should be able to ping 10.0.0.1. We should not be able to ping .2, as is the case, and we should be able to reach .3, as is the case. If you're a Mac user, you're in for a little bit of a more complex process at this point. You're going to need to use a tool called Apple Configurator 2. This is a tool that allows you to configure the mobile config profiles that Apple uses to provision various settings on iOS or macOS. Very commonly used for wireless network provisioning, but also for various other MDM type settings that could be exchanged through this. And these profiles support payloads, and for our configuration here, there's actually a total of 3 payloads that you would normally use in a VPN configuration. Configuring this VPN natively on the macOS tools is not going to give you the right level of configuration. So you'll be missing some options, and for some reason Apple doesn't expose them natively. You have to rely on these profiles. And so the payloads that we have in our profile here consist of the certificate itself that we've already requested. In order to get it there, you have to ensure that it's been imported in your keychain previously, so you can't really just put it in this profile. And then from the keychain, you have to export it in a PKCS12 format, and then you would need to re-import it inside this mobile config profile, which is a tedious process to say the least, but eventually it'll ask you to to put the PKCS12 password if you don't want to be prompted every time. But past that, this profile contains everything that you need to connect. It's important to note also that at that point, once you've done this, this profile becomes very important because it's your key to connect with your identity. So I'm not a big fan of this process because it doesn't allow you to specify usage of an existing certificate or just ask the user for a certificate. But that's what I found works so far, at least. And you are also importing the CA certificate that you want to trust. And so this certificate is the one that we've been working with since the beginning. And finally, in the VPN section, this is where there's a little bit more complexity here. So you're going to be defining a connection name for the VPN tunnel. You'll be defining which host name or server you'll be connecting to. And then on the remote identifier, you'll be defining what the ID of the server certificate is on the EAP side. And we've by far so far understood that this is the WinAD certificate, the FortiQC.local cert. Our local identifier is going to be our user principal name. We're not going to do any machine authentication because we're not authenticating at the IKEv2 layer, we're authenticating at the EAP layer. This is what I suspect is the issue if you try to configure it using the native IKEv2 VPN panel config on OS X. It probably uses machine authentication, and that's why it fails to authenticate if you're using a Microsoft NPS backend for EAP-TLS at the very least. And then past that, we're going to specify which CA we want to find as far as the issuer of our certificate. We're going to repeat the server certificate name again, right? Turn on EAP, make sure that we're picking that certificate that we've imported previously in the payloads, and then check that use IPv4 v6 internal subnet attribute. This is Apple's way of saying enable split tunnel. But remember, there's a limiting factor here. It only will deal with the first entry in the split tunnel list. At least that's what I could make it work like. So I wasn't able to get more than one subnet entry to be supported in there. I'm not sure why. Probably someone has any idea on this, they can post in the comments. Once you've done your configuration and the IKEv2 profile, you'll need to save that file and then double click the file on your Mac, and it will configure a mobile profile. The mobile profile is going to be located inside your profile section of your control panel. Once you've configured that profile, you'll save the file and double click on it, and it will then ask you for your password a few times, but then we'll proceed to import this profile inside the profile section on your Mac. And there you should find the various configuration options, at least in a summary format that you configured in this profile. This should then allow you to connect via the network panel. So if we go back to the network section here, and then we head into the bottom section, we have our test VPN, and we hit connect, and we are connected. As I now have my Mac and a PC for testing purposes that are connected at the same time, I can also validate that the Mac, which is user 2, and remember that user 2 is group 2, and group 2 has access to the .2 address, the .3 address, and should be able to ping the other peer. I'm not too sure which address we have on our side here, but I will take a look here quickly. So if we take a look at the addressing information, we should be able to find our VPN interface. I'll do something clever here. Change the keyboard language first. 1058.58. That will be more helpful if I do a grep on this. So our IP address is 1058.58.2, and I'm able to ping 1058.58.1, which is the remote peer. And I should be able to ping 10.0.0.2.3, but I shouldn't be able to ping .1, and that's important. I've been mapped to the correct policy at this point. And if we take a look at the monitor under the FortiGate device, under IPSec monitor, I can see that I have user 1 at FortiQC.local and user 2 connected currently. And that would be the Windows and the Mac computer respectively. So both of our users are connected at this point, and they are seen as IPSec connections. That's what is IKEv2 basically behind the scenes, and that's it. So a little bit of a complement of information here. I built a little workflow here to explain the components that are at work here in an IKEv2 negotiation, where we're going to be using an EAP type. So we have a client, a FortiGate, and the Radius server behind the FortiGate, which is our NPS server running on a Windows server. And with an IKEv2, we don't have a phase 1 and phase 2 concept anymore. We have phases that are named. The first one is IKSA init. This is where we decide what protocols we're going to be using. So if we have a commonality agreement at this point, then we will generally pass that, have a form of secure channel established, so that it doesn't mean that the peers will be able to connect or will accept to connect at this point. It just means that they have established a means to exchange information in a more secure fashion at this point. And then past that, we're going to have an authentication phase. This would normally stop at this point if we were using either pre-shared keys or certificates within the IKE specification, but because we're using EAP within this phase, there is information exchange to the effect that we're going to have an EAP exchange to proceed, and FortiGate at this point becomes a middleman where information is relayed between the Radius the client that is trying to connect and the Radius server, which is the NPS server in this case. There's a lot of steps in EAP-TLS. I'm not going to explain all of this. You can go and read the RFCs. And I've discussed this before, but the client is going to perform a set of checks on the server certificate, and the server will do likewise for the client certificate. So the typical settings and validations that have to do with certificates are being performed here. Are the host names matching? Do I trust the issuer? Is it valid from a time standpoint? Is it still valid because it's not revoked? There's a CRL checked against this certificate to make sure it hasn't been revoked by the administrator. And does the certificate have the right extended key usage? So the client needs the client authentication key usage, and the server needs the server authentication key usage. The server performs pretty much the same set of checks. On the Windows side, obviously, it will check whether there's a user principal name in the subject alternate name. This is how it knows which user is trying to connect with this certificate from an Active Directory standpoint. And then finally, whether that user is authorized. That's more of the NPS side of the exchange, where NPS will try to match the correct policy. And as long as that user is a member of a group that's got an authorization to connect, then it should allow the connection to go through. It will return that Fortinet group name attribute that we've discussed already, which is what's going to allow FortiGate to map that to the correct group. And that will be the same process whether you're using IKEv2 or IKEv1 with FortiClient or with any other standard compliant client. It would be the same process for SSLVPN also. The moment you're using Radius, the Fortinet group name attribute is what's being returned in order to map users to specific groups when we're using Radius. This concludes this walkthrough. I hope this was useful information. If you have any topics you'd like us to cover, by all means, please let us know in the comment section. We'll put some additional links in the comments so that you can refer to those as they relate to this demo. Thank you for watching. Have a great day.